ஆரம்பிச்சிடலாங்களா?
எல்லாரும் வந்துட்டாங்களா?
கொஞ்சம் வந்துட்டாங்க. அவங்க வந்துகிட்டே இருப்பாங்க. நீங்க அது வந்து லைவ் ஸ்ட்ரீம் ஆகும். அதனால வேற வேற யூடியூப்
ஓகே
அதெல்லாம் பார்ப்பாங்க.
ஓகே.
தொடங்கலாங்களாங்க?
தொடங்கிடலாம்.
அனைவருக்கும் வணக்கம். அனைவருக்கும் வணக்கம். இன்றைய நிகழ்ச்சிக்கு திரு அபிநந்தன் பாலச்சந்திரன் அவர்களை வரவேற்கின்றோம். அவர் இன்றைக்கு தமிழ் லாமா லார்ஜ் லாங்குவேஜ் மாடல் என்ற தலைப்பில் உரையாற்ற உள்ளார். குறிப்பாக அவர் கேபிஆர் கல்லூரியில் தமது பொறியியல் பட்ட படிப்பை முடித்து ஏஐ துறையில் பல்வேறு ஆராய்ச்சிகளை செய்து கொண்டுள்ளார். அவர் பல சிறப்பு பரிசுகளையும் பெற்றுள்ளார். காகுல் நோட்புக் மாஸ்டர், டிபியூ ஸ்டார் அவார்ட் காகுல், ஃபியூச்சர் ஆஃப் ஏஐ டெக் ஸ்பீச் என்ற சில சிறப்பு அவார்டுகளையும் பெற்றுள்ளார். அவர் மெஷின் லேர்னிங், ஏஐ டெக்னாலஜி போன்ற பல துறைகளில் தனது ஆராய்ச்சிகளை தொடர்ந்து கொண்டிருக்கின்றார். இந்த அறிமுகத்துடன் திரு அபிநந்தன் பாலச்சந்திரன் அவர்களை இந்த நிகழ்ச்சிக்கு வரவேற்கின்றோம். அபிநந்தன்.
ஹலோ சார்.
நீங்க
மிக்க நன்றிங்க. இப்போ செஷன் ஸ்டார்ட் பண்ணிடலாங்க.
ஆரம்பிக்கலாம்.
ஐ ஹோப் மை ஸ்கிரீன் இஸ் விசிபிள். எனக்கு ஆக்சுவலாக தமிழ்ல பேசி பழக்கம் இல்லை.
இது நியூஸ் இந்த நேரத்தில் நம்முடன் அரசியல் சேர்ந்திருக்கிறார் மூத்த பத்திரிகையாளர் மணி அவர்கள். வணக்கம் சார். பிரதமர் மோடியை வீழ்த்தறதுக்கு அவருக்கு பிறகு அவரை வீழ்த்ததுக்கு வேற யாரும் இருந்தாலும் அவர் வந்து பாதையில பயணிக்க வேண்டிய சூழ்நிலை. அதன்படி பார்த்தா மத்திய பிரதேசத்துல கமல்நாத் வந்து அந்த பாதி தான், அந்த சவுத் அந்த அதை நோக்கி நகர்ந்தாரு செஞ்சாரு பார்த்தோம். பட் அதுவே கை கொடுக்கல அப்படிங்கும் போது இப்ப இனி மோடி வீழ்த்ததுக்கு என்ன மாதிரி நான் பாதை வகுக்க வேண்டியது போராடி
சார் வேற ஏதோ சவுண்ட் கேக்குதுங்க.
இது உங்களோட லெக்சர்ல இருக்குங்களா?
இல்லைங்க.
என்ன ஆப்ஷன்
இருங்க, எல்லாரையும் மியூட் பண்ணிடுறேன் நான். அப்புறம் நீங்க வந்து
பிளான் பண்ணாங்க. காங்கிரஸ் ஸ்ட்ராங்கா இருக்க இடத்துல மற்ற கட்சிகளா ஸ்ட்ராங்கா இருக்க இடத்துல காங்கிரஸ் எல்லாருக்கும் காங்கிரஸ்.
சார் யாராவது பார்ட்டிசிபென்ட்ஸ் யாராவது
என்ன பண்ணிருக்கோம்? முதல்லயே பார்லிமெண்ட் எலெக்ஷன் வேற, அசம்பிளி வேற, அசம்பிளி அசம்பிளிக்கு அப்பவே பல விமர்சனங்கள் வச்சாங்க. இப்ப சண்டை போட்டுக்கிறீங்க, இன்னும் 6 மாசம் வர எலெக்ஷன் எப்படி ஒற்றுமை அமைதி என்ன பண்றாங்க? தெரியப்பட்டது காங்கிரஸ் ஆணவம் மட்டும் போல, ஆண்ட பரம்பரை போல அனுபவிக்கும் தேர்தல் அப்படியே
இது எங்க இருந்து யாருகிட்ட இருந்துங்க?
மாநில கையில அதுவும் போயிடுச்சு.
அபிநந்தன்
தெலுங்கானா கிடைச்சு சொல்றாங்க.
தெரியலைங்க
இந்த
யார்கிட்ட
மகிழ்ச்சி
இருந்து
கொடுக்குறாங்க.
வருதுன்னு.
ஆனா இதுல உள்ள ஃபேக்ட் என்னன்னு பார்த்தா
எல்லாரையும் மியூட் பண்ணிட்டேன், அப்படியே அது லைவ் ஆயிட்டே இருக்கு.
காங்கிரஸ் இந்த அளவுக்கு வலிமை இருக்கு அப்படிங்கறது ரேவந்த் ரெட்டி தான் காமிச்சாரு. அவர் தன்னெழுச்சா சில கூட்டங்கள் பேரணிகளா நடத்தி டெல்லிக்கு வந்து இப்படி ஒரு விஷயம் நம்மகிட்ட இருக்கு அப்படிங்கறத காமிச்சு அதன் காரணமா தான் வந்து அப்படி ஒரு ஒர்க் நடந்து இன்னைக்கு ஒரு வெற்றி நோக்கி நகர்ந்திருக்கு. இதுவே அவர் காமிச்சதான் டெல்லி காங்கிரஸ் அரசு அதை கூட கட்டுக்கலாம். கண்டிப்பா
இப்ப நீங்க தொடரலாம்.
Hello. Hello. I hope everyone can see my screen. So now let's start the session. So first of all, thanks a lot Input for giving me this opportunity to share my recent work regarding one of my recent research in AI. So this is about LLaMa. LLaMa is a large language model that can generate fluent text in Tamil, the first of its kind. There are no other open source language model that can generate fluent text in Tamil in the 7 billion, 13 billion parameter categories. With the recent advancements in like ChatGPT and all of the AI tools that have come out recently, there are also other open source initiatives going on in the same space. So that is exactly where this research comes in. Most of today's generative AI tools are built on LLMs trained on text only in English or in European languages, leaving the rest of the languages out. It's not that they cannot generate text, but they're not tailored specifically for languages like Tamil, which have deep-rooted culture. So in this session, we'll cover a high-level overview of how LLMs work before getting into how Tamil Llama was developed, and you might also use this as a reference to build your own language models uh, that can be fine-tuned for your own use case. And the good thing is the research paper, the code, and the model and everything is open source. So you can just Google search Tamil Llama and you'll easily be able to find the research paper and other things. As you can see, this was published about a month ago, and it is already downloaded by about 3,400 people. So before getting into the technical side, so I just want to showcase some of the results from the model. I hope this is familiar to you because a lot of us these days have started using ChatGPT, Google Bard, and other tools, other AI chatbots. So this is similar. So, but this built specifically for Tamil. So here I start with Vanakkam, and the model responds back with Vanakkam, நான் உங்களுக்கு எப்படி உதவ முடியும்? And then I go on to give it a task, a coding task to upload a local file to Amazon S3 bucket. So it is able to write the code. Although not perfect, it's able to write a working code for this. And then I ask a question regarding the code that the AI model has written, and it's able to respond back for that query as well in fluent Tamil. So this is the kind of model that we are going to talk about in this session. A model that can respond back to the users in meaningful ways, and also perform the instructions in a helpful way for the user, just like how ChatGPT and other models are working. So there are a lot of large language models out there today, but all of this surge in heavy open source research started exactly a year ago after ChatGPT was introduced. But the roots for all the innovation started much earlier in 2018, when the transformer language model was introduced by Google. So the transformer language, the transformer architecture was very important for the entire NLP ecosystem, because that's where all the innovations happened. It was the foundation of all the innovations that are happening today. We begin in 2018, where there were models like Word to Vec and Glove, which laid the groundwork for understanding simple text processing, and for deeper semantic understanding, the models were being used. But the real lesson came when the transformer-based variants were introduced in like 2019 to 2020 period. That's when we started seeing some serious applications and major leaps forward in natural language processing applications. And that also revolutionized the way machines understand human language. Fast forward to today, there are models that can generate human-like text, which is a huge breakthrough. Like models like GPT-4 are even better than humans in certain benchmarks. So, but the glaring omission here is that all of these models work in English or other European languages. None of them are specifically tailored for Tamil. So that is the gap that LLaMa addresses here. Before moving into those details, let's first learn some basic high-level overview about how large language models work and what they are. So large language models are nothing but machine learning models that are trained on huge amounts of data from the internet. So after training on huge amounts of data from sources like web pages, web documents, and social media posts, and countless other possibilities, they become very useful for a lot of use cases. LLMs are composed mainly of, they basically contain a partial representation of the entire internet. So when we query it, depending on what it has seen, it will try to respond back. So depending on this, these models can be adapted for tasks like text generation, where if you want to write a letter to someone, these models can help you with that. And also for assistive style chatbots, the example that we just saw in the couple of slides back, where the model was able to generate code and also explain it to some extent. So those are the kind of applications that these language models are capable of. And what are actually language models doing? So what language models actually do is they, depending upon the context or the sequence of given a sequence of tokens, they predict the next token. So basically they do next word prediction. So in this example, if you input a text like my name is predicting the next possible token, the probability of 61%, as John. So the completion will be my name is John. So it basically predicts the next words given a sequence. So that's all that it's doing. But the LLMs are autoregressive in the sense that whatever is predicted is given back, and then we do it in loops so that it generates the entire sentences and paragraphs. The reason why next word prediction actually works is in order to predict the next word accurately, it turns out that the model has to learn a lot about the world, and also the semantic features of the language, and also a lot of subtleties in the language for it to be able to answer effectively. So with large amounts of data and powerful models trained this way, we are able to get very capable language models that can generate human-like text. So this is a very high-level overview of how LLMs work. So if you are interested in diving deep, I would highly recommend looking into Andre Kapathi's recent video on this, how LLMs work. But this is just a very high-level overview of how they work. Given a sentence, what it basically does is it splits those sentences into multiple parts. It could be words or subwords, as seen in the example here. Special relativity was described by Albert Einstein. So here relativity is split into two tokens. So the tokenizer is the first step of the process, where the given input sentence is tokenized into several parts, and then it's given to the embedding layer, where the model learns about the actual meaning of these words. So it's in a higher dimensional vector. The model tries to learn a high dimensional vector in the embedding layer for each words. So the advantage of this is similar meaning words are positioned closer together in the high dimensional space. So that is the reason why the model is able to actually distinguish between the words and the subtleties in the language, not just by it doesn't actually see the words. They just see some very huge vectors. So on that high dimensional vector, we had a positional encoder, because these language models do not have sequential awareness embedded to it. So positional encoding is a technique where sequential awareness into the input, so that the model knows which word came first and which word came second, and so on. And then it's given to the transformer layers, the transformer decoder layers in this case specifically. That's where the real magic happens. So here there could be multiple layers. Maybe the LLaMa model, for example, has a lot of layers in between, and after that it does some very complex mathematical functions, and then the resultant output is converted into probabilities based on the original vocabulary of the language that we're training it in. So in this sentence, the sun rises in the next word is actually east, right? So as humans, we're able to easily predict it. But for language models, when trained on extensive amounts of data in this way, they will also be able to predict the next word pretty accurately. And that word has to be part of the vocabulary. Even if it is not part of the vocabulary, in some sense it can work, but the efficiency will be a slight issue. So here, the language models that we are talking about are trained on internet data. So the main problem comes here because most of the internet is in English and other very common European languages like Russian, Spanish, French, etc. Although in reality, the most spoken language in the world is Chinese with 1.2 billion people, and comes the other languages. But to stark contrast, what happens is the internet doesn't contain enough data in languages that are spoken by millions and millions of people, like Tamil. Tamil is, for example, spoken by 90 million people across the world, and it contains very small amount of data on the internet. So when these large language models are trained on internet data, so if they are not supervised properly, so what happens is that these languages are being left out, And this imbalance is also seen in the abilities of these AI models. If you see the LLaMa 2 language model, which was released by Meta earlier this year, which is one of the very famous LLMs out there, open source language models out there. So since it is open source, we can look into how it was trained and all of the other technical details that went behind developing the model. We can see a very concerning reality. As you can see here, 89.7% of the data that was used to train LLaMa 2 is in English. So the rest of the 8.4% is unknown. Unknown meaning it could probably be code, programming language, languages like Python, JavaScript, C, or whatever. So those are the unknown category, and then the rest are about very tiny fraction, like 4% or something. I don't know, or 2% or something. It's in European language, and very small percentage of the data, like 0.2% of the data contains the rest of the languages, like Tamil, Hindi, Chinese, or whatever. So this is the reason why we are not able to get these models to respond properly to Tamil instructions. And Tamil LLaMa, this served as an inspiration for me to develop Tamil LLaMa language model to extend the training stage to include a lot of Tamil data, and then to possibly create a assistant style language model that can respond to user queries in an effective manner. There are tons of open source language models these days. There are a lot of them. I've just taken a few. For example, one of LLaMa 2 70 billion developed by Meta is the only open source model here. The other one is ChatGPT, which is indeed very famous. And then there is GPT-4, which is arguably the best model, AI model out there currently. So if we see LLaMa 270B, I hope this text is visible. When prompted with Tamil inputs, the model either responds back in English, or or it just understands the meanings of the word and cannot do whatever we requested it to do. As seen here, the prompt here is விரைவாக தூங்குவது எப்படி, how to sleep faster, how to fall asleep quicker, and the model is not able to generate a satisfactory response for this even in English. That means like the model is not even able to understand what we are talking about. So that's mainly uh, because of the lack of training data in Tamil also. But if you see ChatGPT, it tells a different story. It is able to respond in Tamil, but the responses are not that coherent, because it makes a lot of mistakes. So when I ask the same prompt here, it is able to respond back, but it says it also responds with some gibberish. Like look at that, look at this part over here, where where we cannot understand what it really is trying to say. So even ChatGPT cannot be used for Tamil communication, for assistive style prompting in Tamil. To some extent, it is possible, but in most cases, it fails like this. But it's a very different story when it comes to GPT-4. GPT-4 does respond back in Tamil, and it is also able to respond back in a very effective way. So that means something has changed in between ChatGPT and GPT-4, because ChatGPT is nothing but the GPT 3.5 model, and GPT-4 is like an upgrade of it. So I guess OpenAI has introduced a very diverse data set during the training process of GPT-4, or either it is very good at picking up languages. So we use GPT-4 as a reference point from here on to develop Tamil LLaMa 2. And in terms of understanding what the LLaMa models are, LLaMa is a It's a family of language models that were released by Meta in 2022, that which really revolutionized the open source AI community. It serves as the backbone on most of the open source models, and there were earlier version LLaMa 1 as well, which came out later, earlier in 2023. It comes in 4 different sizes with 7 billion, 13 billion, 33 billion, 64 billion. So these billion parameters are nothing but how deep the neural network is. As we saw in the first few slides, there was just a high level example, right? There was transformer decoder layers. So there are a lot of these decoder layers. We can imagine that's going to be very deep. So the bigger the model, the better the performance is these days. Since we have a lot of data, the LLMs scale really well with data as well as with a number of parameters. So the earlier models had a context length of 2000, which means at once how much information that they can hold, or depending on how much input that we can give to the model at once. So the context length is basically doubled for LLaMa 2, and it was also trained on double the amount of data. This, as we can see, so this is a comparison between some of the open source LLMs and LLaMa, and also ChatGPT and LLaMa 70 billion. So here we can see that the LLaMa 2 70 billion model is able to either beat ChatGPT uh, or match it in many cases, and it's doing much better than the open source counterparts that it has. So that is the reason why I went with the LLaMa model, LLaMa 2 specifically, in order to adapt it for Tamil. So basically what was done is we take LLaMa 2 as a foundational model, and then we adapt it for uh, Tamil language specifically. So in order to understand how that can be done, first we have to understand how LLaMa model was trained. So the LLaMa model, there are few stages that are involved when training a model. There's pre-training, as I said, on large amounts of text data from the internet to do next word predictions. That's going to be really unstructured and kind of a messy data set. So at the end of the day, the model does very well in next word prediction tasks, but it doesn't really help much from there. It serves as a great foundation model, but it needs to be further fine-tuned in order to be able to make it work like ChatGPT and other models where as humans we can interact with. So there are 2 stages here. Pre-training, as we say, a large amount of text data, we train the AI model for a longer period of times, and then obtain a foundational model. From there on, we introduce what is called a supervised fine-tuning. So that means we take the foundational model, uh, which is now going to be trained on data that is carefully crafted in a way that it helps the model to respond to user instructions more clearly and efficiently, like in a more helpful manner, and also uh, without having any harmful responses back. Those are the 2 major stages involved. There is also an optional third stage where we can hire a lot of uh, humans, and then we could do something called as RLHF. That's a pretty complicated process, but that is that in modern LLMs that's performed very extensively, and that is proven to be the key factor in getting these models up to speed. And this is the exact same technique that was used to train the GPT 3.5 model as well. So we've already discussed about the size of the data set, the size of the model. Obviously, the model, the training these models require large amounts of computes. when developing these models, Llama 2 family of models, Meta has estimatedly spent around $20 million in training these models in large amounts of text from the internet. So that is the kind of uh, cost that's going to be the training these language models is not an easy task. It's actually very expensive that not individual researchers or even small scale teams cannot actually afford it. But the great thing is, since these models are already open source, we can use them as a starting point and adopt them to our own specific use cases without spending a lot of money. In fact, we could even fine tune the Llama model for free in Colab notebooks or and other free hardware out there. So yeah, also it also the training period is very long and it will take a lot of days. So the foundational models that we get out of this huge process can be adapted for other languages as well. That is exactly what the Chinese had done. So when I was looking at how others have done it for their own languages, I saw a few models, especially in Chinese and Swedish and even Russian, all of that. Everyone, what they were doing is they were using Llama 2's starting point and then training it, extending the training stage on their own language dataset, and then obtaining a model for their language. So that was the inspiration for me. So I thought about following the same method, and that's how Tamil Lama was started. And there are a lot of challenges as well for developing LLMs for Tamil and other Indian languages. So there's a severe lack of high quality data sets. Uh, there are data from Wikipedia. And apart from that, there are not really instruction data sets available. For example, if you are going to train a model in English or Chinese, the chances are that you'll have a lot of really high quality data. But for Indian languages, the number of high quality or even data sets that exist are very few in number. And these instruction tuning tasks specifically requires a lot of carefully crafted data. So there a lot of research needs to be done in this space for more innovation in for Tamil and other languages. And also the limited vocabulary of existing models. We've already seen that the data that was used to train these models were minuscule in fraction compared to other languages like English and European counterparts. That is not the only issue here. The limited vocabulary, that means the model only has a fixed set of vocabulary. That means as humans, we cannot speak in a language that we don't know, right? So in order for us to learn a language, we need to understand the words. And even before that, we need to know the words in order to be able to at least put together a sentence. So since there are almost no words from Tamil in Llama and other open source models, this is a huge challenge as well. We need to extend that vocabulary uh, with that is representative of the language for us to see really great results. And there are also huge lack of evaluation benchmarks. Even if we uh, develop the model, there are a lot of challenges in evaluating the models, and there are no proper benchmarks. For English and Chinese, for example, for English, we have a lot of benchmarks like GSM 8K and HellaSwag, Human Eval, and a lot more. And for Chinese, they have C Eval. And so a lot of research is happening from the Chinese and other end to make sure that AI technology is being actively adapted to their language. But that is not the case for most Indian languages. We don't really have any benchmarks at this point. So we need to rely on either manual inspection or use superior models like GPT-4 to act as an evaluator. So those are the challenges in building the LLMs. And we just discussed about the problem in lack of vocabulary. So this example illustrates that more clearly. This is GPT when prompted in English with the word "the sky is blue," uh, and look at the and also with the similar Tamil sentence called "Vanam Neelamanadu," which are both have the same meaning, similar length, 16 characters and 15 characters over here, similar length, similar meaning, but English sentence is getting tokenized into 5 different tokens. But the Tamil sentence that we just inputted here is getting tokenized into 25 tokens. That's like 5 times increase in the number of tokens that are required to represent the language in the model. So that is one of the reasons why the generation is slow, and also the generation is not so coherent, because these are byte tokens actually. So in order for the language model to not very confidently learn the linguistic patterns in the language, at least it needs to have proper words and subwords in its vocabulary. Unless the language model is really huge and seen a lot of data. And we have seen the GPT example. Let's look at the open source model LLaMa example here. For English, when given the exact same sentence, "the sky is blue," LLaMa tokenizes it into 6 tokens, whereas the Tamil word with exact same meaning and similar token size is getting tokenized to 19 tokens, which is 3 times more than the English input. So that is again one of the reasons why we are not able to see great performance in LLaMa for Tamil. This is also the case for many other Indian languages. So adapting these open source models for other languages like Telugu and Hindi is going to be the same. The process might actually be the same as how I've done for Tamil LLaMa. So these are the key contributions from the Tamil LLaMa research. The first contribution is, of course, the vocabulary expansion, because that is the first thing that we need to improve in the model in order to uh, improve the encoding and decoding proficiency of the model. The LLaMa 2 tokenizer has a vocabulary size of 32,000 tokens, which consists of languages like English, Spanish, and Russian, and a lot of other languages. We extend that 32,000 words in the vocabulary by an additional 16,000 Tamil tokens, thereby expanding its vocabulary significantly for Tamil, so that it is able to generate text in Tamil very effectively. So next is Tamil instruction in evaluation datasets. As I said in one of my previous slides, lack of high quality data for fine tuning is one of the major roadblocks in adapting these huge LLMs for Tamil and other languages. So what I have done is there are very famous datasets like Alpaca and Open Orca dataset. Alpaca, for example, was released by Stanford University, and it contains instruction style input-output pairs, which are proven to be effective. And although not perfect, it's a great starting point. And there is Open Orca dataset as well. Orca was introduced by Microsoft, and Open Orca is like an open source replication of the same procedure. And these are the two datasets that I use to train the Tamil LLaMa model. These datasets doesn't have any Tamil data, but to get Tamil data, what I actually did was to translate those into Tamil. And translating that comes with a lot of challenges as well, because just translating a data set will not work out, because how would you translate the coding parts, for example? So these instructions might also contain programming code. So that has to be manually supervised. So with a little bit of manual supervision and mostly automation, I was able to translate these uh, open source high quality data sets for Tamil. And these can be used for instruction fine tuning, but they cannot be used as evaluation data set, because evaluation is a different thing. So that is an area of still an area of active research. And the third key contribution from this research would be the Tamil LLaMa models themselves. Uh, Both the foundational and the instruction following models are open source. So if you want to fine tune the Tamil LLaMa model for your own use case, just take the foundational model, uh, prepare a data set specific to your use case, like maybe an AI salesperson. So you could just create your own data set and fine tune your model for that specific use case, uh, since these models are open source. So now I'll explain a bit about how the Llama 2 vocabulary was expanded. Uh, First, I took a large Tamil corpus, text corpus, which was taken from. There are a lot of data sets in Hugging Face. I just took something that has a lot of data, and that was Culturax data set, and I trained a sentence piece model on top of it. To sentence piece, there are specific ML models that can learn to split up natural language words into subwords. So you can think of sentence piece to be one such model, where it could be used for creating the vocabulary. So I trained a specific model called BP model, which is also uh, which follows the exact same tokenization style of the original LLaMa model. So, and then once we train a new model that can now, given an input text, this model will now be able to split it into meaningful parts, into words and subwords, depending on the data set. So this is also really important. So this data set has to be representative of the entire language. So it has to contain most of the common words and all of that. So once that model is trained, we get an updated vocabulary. So that vocabulary, the size of that vocabulary, as I previously said, was set to 16,000 tokens. And those 16,000 additional tokens that we get out of the BPA model is extended. So we take the original LLaMa tokenizer and extend it. Has a vocabulary of 32,000 tokens. We add a 16,000 other tokens on top of it to extend the size of its vocabulary for it to be able to uh, effectively and coherently generate text in Tamil. So the result of this is the LLaMa tokenizer with extended Tamil vocabulary, which can now be used for a lot of different tasks. First thing is fine tune it for we have to create the foundational model. So we'll get to that in a moment. So once after we get the Tamil LLaMa tokenizer in this process, uh, let's just compare how good it is. So here is an example Tamil text. This is taken from the official paper. So here is the example Tamil text. தமிழ் உலகில் உள்ள முதன்மையான மொழிகளில் ஒன்றும் செம்மொழியும் ஆகும். So this text right here contains 67 characters in this text. For LLaMa 2 tokenizer, for it to tokenize it, takes 89 different characters, because it doesn't really have any Tamil words in its vocabulary. It relies on byte tokens like this to encode it. So this isobit is 89, but the new tokenizer that we have obtained as a result of the previous process is only the length of that is only 18. So the Tamil Llama model is like a lot at least 5 times better than the original Llama tokenizer for representing Tamil language. So as we can see here, this is an example of GPT 3.5 and GPT 4's tokenizer from OpenAI. So the exact same sentence takes 89 tokens for GPT to tokenize, which is actually similar to exactly the same as Llama model. So this the Tamil Llama tokenizer vocabulary expansion has given us massive improvement over the existing models already in terms of representing Tamil language efficiently. So the reason that this is important is this is very important for the model to learn the linguistic subtleties in the language, and also imagine a situation where the model for one sentence the model has to generate 89 tokens here, but the expand due to the extended vocabulary, Tamil Llama just takes 18 tokens, so that's like 5 times faster than the other models. And also remember that by extending the original vocabulary, we are not really hampering the existing vocabulary. By just extending it, 32,000 tokens are now going to be added with another 16,000 tokens, which is 48,000 tokens. So the model still retains its English text generation capabilities, while also we have set a good starting point for us to train this model on large Tamil datasets. So the uh, training process is the high level view of the training process goes in like something like this. We take the Metas Llama 2 foundational models. We do the vocabulary expansion as we just discussed in the previous slides. And then we pre-train the model. The pre-training phase is where we give it uh, terabytes of text data uh, to train it for longer periods of time. So in this case, that was going to be really expensive. Like if Meta is able to train it in 20 terabytes of data, that was running for a lot of days. Of course, that is going to be incurring huge costs. As an individual, that is not possible for me. So I have to rely on really good quality subset here. Like I just shortlisted 12 gigabytes of pre-training data for this purpose, and trained the original foundational models on this 12 gigabytes of Tamil data. And I just expected, I hoped that the model would pick up the uh, linguistics pretty well and be able to generate Tamil language fluently. And once we pre-train it, we'll get the foundational model, Tamil Llama. It's going to be the foundational model for us here, which the foundational model is like a beast that is yet to be tamed. I would like to think of it that way. Uh, so this should be further fine-tuned for downstream tasks in order for normal person like you or me to use it. So for further fine tuning, as I previously mentioned, we take the Alpaca and OpenOrca data sets, translate it to Tamil, and then clean it up, do all the data processing that's needed, and then feed those 145,000 instructions to this model and train it for a couple of epochs. So it's trained on 145,000 instructions across various domains like question answering, translation, coding, and open question answering, reasoning, and a lot more. So as a result of this process, we get the Tamil Llama instruct model, which can also be called as a Tamil Llama chat model. Okay. It's not exactly chat, but it can be used for chat some extent. So here are some of the results from the pre-trained model. The pre-trained model, as I said, is the foundational model, which is really, really important. We need to see the model able to generate good Tamil text as a result of this process, and also much quicker than what was seen previously. And that is exactly what I saw after completing the first phase of training, because a few of these responses blew my mind because it was already capable of doing some reasoning. Because here I'm asking it in English, what is the meaning of the word chronological? Explain in Tamil. It is able to explain the meaning for the word chronological in Tamil, and then I'm asking it the meaning of another word, sequential in Tamil, and then it's also again able to explain it. And then we are asking what is the difference between the word sequential and chronological in explain in detail in Tamil. It's able to come up with a fairly decent explanation on that. So this was really motivating for me because the foundational models, when the foundational model is really good at generating Tamil text without any like spelling errors or grammatical errors, that's a really good sign that the model has come out pretty well. So as you can see on the right, so it can also still generate text in English as well. For example, I've prompted it with an English sentence Virat Kohli has. As we discussed previously, these are just next word predictors. So they just auto-regressively predict the next word. So when I say Virat Kohli has, it predicts Virat Kohli has now scored more runs in T20 than any other batsman in history. This is actually accurate, right? Virat is the leading run scorer in T20 Is. And I'm giving the exact same prompt in Tamil and giving back some response which are also relevant in Tamil. Like Virat Kohli தான் இந்தியா அணியின் கேப்டனாக இருக்க வேண்டும் என முன்னாள் வீரர் சச்சின் டெண்டுல்கர் கருத்து தெரிவித்துள்ளார். So that really shows how useful the models are, since it can understand both English and Tamil. If fine-tuned with both English and Tamil data, it can very well be a very great multilingual chatbot. So these are the results from the first phase. And the next stage is the fine tuning, where, as I said, we fine tune the model on downstream tasks, where we give instructions like summarize the following text and give it a very high quality instruction. And also I translate this into a Python code. So a lot of these other instructions, which we are now going to use it to train the model, so that the model has model learns to respond to user instructions in a specified way. Because when I say summarize the following text, it should actually know that the user is looking to summarize an input text and what exactly it needs to do. So the fine tuning is also a very important stage. And as I say, the translated Alpaca and OpenOrca datasets are used for fine tuning. So these are the prompt templates that are used. And here is one such example instruction where we give this is the top prompt is called as a system prompt, where we say ஒரு பணியை எவ்வாறு நிறைவேற்ற வேண்டும் என்று கூறும் அறிவுரை கீழே உள்ளது, and like given a task, respond as much as help be as helpful as possible while responding in a helpful manner. So that is kind of like the system prompt that we give, and then we give it a task. பின்வருவனவற்றை விலங்குகள் தாவரங்கள் மற்றும் தாதுகள் என வகைப்படுத்தவும். So it's like basically a classification task where we ask the model to classify the different words into categories, and it goes on to do that correctly. So these are the instructions instruction and input response using which we train the model. And at the end of the fine tuning process, the model will be able to understand and generate text like this, understand user instructions really well. So here are some of the results from the fine-tuned model, fine-tuned LLaMa model. So here's a question here. மேஜில் 4 ஆப்பிள்கள் இருந்தன. குமார் ஒன்றை சாப்பிட்டான், ராம் எடுத்துக்கொண்டான் 2, மீதி எத்தனை ஆப்பிள்கள் உள்ளன? So there are 4 apples on the table. One person eats away 2. How many apples are remaining in the another person took away the other 2 apples? How many apples are left. It's not asking how many apples are left in the table, how many apples are left. And the model is able to accurately tell the answer for this. And also, we give it a translation task, and the model is able to translate the given English text pretty accurately in Tamil. Even the 13 billion model, as expected, is performing way better here. And given coding task like implement quick sort in Python, so the Tamil LLaMa model is able to, given Tamil instructions, it is able to generate the code for it. And it is also able to respond to open questions uh, like decide, helping the user decide whether or not to buy, whether or not he should buy an iPhone 15. So it comes up with a really impressive answer, telling that he should first understand his budget and then evaluate all the options and then take a decision appropriately. So which is a really great response from the model. And it also excels in some mathematical tasks, although it is not meant for any mathematical or coding tasks. The model does excel in some of these tasks. One such example is given here. Just give a simple mathematical ask it for a simple mathematical solution, 3x plus 1 is equal to 10. And both the models are able to uh, attempt it, identifying what exactly the user talking about. But the 13 billion model is giving the right answer while the 7 billion model is not. With a few mistakes, I think still for the fact that it's able to solve these mathematical problems is uh, a good starting point. And here are some of the results from my other conversations. So here is on the right is an example where uh, I asked it again, Virevaga Tungvadi Eppadi, an example that we already saw. And cleverly, the model asked, do you want to learn exercises to learn quickly, or like have uh, you need to build the habit, or you need to learn the exercise? It's able to ask the user what exactly he needs depending on the question, which is actually pretty impressive, right? And then I say வழக்கத்தை மேம்படுத்துவதற்கான things, and it tells me what changes I need to do habitually in order for me to sleep better. So that is one result, and the other result is here. Here we just ask some factual questions. What is the distance between the Earth and the Sun? It is able to say that pretty accurately, 93 million miles is right, but 159 million kilometers is not. I don't think that is actually right. But anyway, it's actually giving what of the answer, right? And then we go on to ask what is 1 AU. If it is the same as 1 AU, it says yes, it is the same as 1 AU. And then we ask which is the tallest mountain in India. It's able to say that it's Kanchenjunga, which is actually the highest mountain in India. If we exclude the K2, it's located in the POK region. So this is pretty accurate. And also, the fine-tuned model is now a lot more interactable and similar to the models that we are familiar with in terms of ChatGPT and other models. How I evaluated those, now that we all developed the model, we need to measure the performance of it compared to some other models. In this case, I was very interested in comparing it to the ChatGPT, GPT 3.5 Turbo, because it was able to generate Tamil text, which was on and off. But still, it was able to generate Tamil text with at least some meaning. So I used that as an example and used GPT-4 as an evaluator, since GPT-4 is like a supermodel, and from my experience, it was generating really good response in Tamil. Although not at the level we see in English, it was excellent. So I use GPT-4 as an evaluator, which is actually pretty common. Even benchmarks like Alpaca evaluates this technique. So I just gave it 120 handcrafted instructions, and then asked GPT 4 to evaluate those instructions. And depending on that, the 13 billion model was just like we expected, came out on top with a score of 71.17 out of 100. And the Tamil LLaMa model, 7 billion model was slightly behind with 63, but it was both the models were still better than the ChatGPT model out there. So this test was across various domain, various different topics like question answering, literature, translation, and ethics. Some of these performance in some of these areas were expected to be low, like literature, because there was no explicit data that was fed for the model to learn about Tamil specific literature. So the downgrade in performance was expected, and so is the case for like ethics also, because it was not aligned. There is also actually an external stage, as I previously shown. But after fine tuning, we do something called alignment to make the models less harmful, model responses less harmful, and prevent it from responding to dangerous prompts. So that was not carried out in this model. So the performance in ethics category was pretty also expected, but still I was still surprised to see that ChatGPT we were able to using using simple Tamil prompts. ChatGPT was indeed responding in a pretty dangerous way. So that's why the GPT-4 has evaluated it. The score of that is pretty low here. Overall, 13 billion parameter model here performs really well. Apart from just instruction following tasks, uh, the Tamil LLaMa family of models also do pretty well on natural language understanding tasks like uh, sentiment analysis and text classification. The particularly interesting one for me was the sentiment analysis part, where the 7 billion model was able to beat the 13 billion model, which is really uh, pretty great. And actually, the 13 billion model was pre-trained on very 1/3 of the data that was given to 7 billion model. So that could also be a factor here. In order to reduce cost, I had to just give up somewhere. And also in text classification, this Tamil LLaMa family of models in Tamil, all of these evaluations were done in Tamil, and they perform much better than the original LLaMa models. The original LLaMa was actually close to random predictions, so that was actually kind of useless. So it did not really understand Tamil prompts. So the Tamil LLaMa brings about a huge change here, and I'd like to finish by also addressing the limitations, which is it's also very important. The first limitation is constrained knowledge base, because since it was a one-person effort and I had a specific uh, hardware restrictions and all of that, so I could not train it on large amounts of data. So I had to give up on that aspect. But still, even with like 12 gigabytes of data and then 4 gigabytes of data for 13 billion model, the models have come out really well. So, but still, we need to improve that underlying data that was used to train the model. And the second one is the ethical concerns. So these models, although they're great, they can also respond to very dangerous instructions, which is not really good. Because this is another stage uh, anyone in the open source community could also do. Even I am planning to do some LLM alignment in the future to make it more safe, and also it will lack some robustness in terms of it might come up with an answer that is not actually true. That is also mostly because of the training process that was followed here. But other than that, this forms a solid foundation for others to develop on. And also reasoning and mathematical challenges are obviously there. Even the best of LLM struggle in reasoning and mathematical tasks, and similar challenges are also faced by Tamil LLaMa, or even more so, because uh, it was not really specifically trained to answer like complex mathematical or reasoning questions. and over generation tendencies. Sometimes it just generates a lot of text. Not really like when you ask it to write a letter, it will write a very long letter or something like that. So that is one area that could be improved with better fine tuning and evaluation hurdles, as we already discussed. Evaluating these language models is the hardest part, and also translation loss. Uh, Translation means like the instruction data sets are not expert crafted for Tamil, like, right? Because they are just translated versions of English datasets, and then with some manual supervision, I've tweaked it as much as possible. Now, I've not. There are a lot of problems in the dataset still, but I've tweaked it as much as possible, and still it gives a great results. But that is still an area for improvement. If we use a expert crafted dataset, I think we could really improve the performance of these models. And yeah, that's it for this. And I hope you liked this session. And I hope you learned a lot about how LLMs work and how it could be adapted for your language, uh, and how it could be even made better. So yeah, I hope the open source. I believe the open source community will still catch up, and it will. There'll be a lot of new models coming up in the near future for this. Thanks a lot, everyone.
And now the question session. If anybody would like to ask the question, you can ask.
Abinandan is an excellent talk by an expert. And I am not an expert in AI, but I could easily see this in a talk which is given by an expert who has spent a lot of time in understanding the things. And I'm also very thankful ஒரு தமிழ் மொழியை வந்து ஒரு புதிய பரிமாணத்துக்கு கொண்டு போகக்கூடிய ஒரு வேலையை செஞ்சுருக்கீங்க, தொடங்கி வச்சிருக்கீங்க. ஒரு மிக்க மகிழ்ச்சி, ரொம்ப ரொம்ப எனக்கு வந்து ரொம்ப மகிழ்ச்சியை தந்தது அந்த உங்களுடைய முயற்சி. எனக்கு சில கேள்விகள் இருக்கு. இது வந்து ஏஐ வந்து ஒரு ஹியூமன் பீயிங்ஸை மொத்தமாகவே வேலையில்லாதவங்களா மாற்றிடுமா? இப்போ நீங்கள் டிரான்ஸ்லேஷன்லாம் சொன்னீங்க, பாலச்சந்திரன் அப்பாவுக்கும் இப்போ எங்கள் ஒய்ஃப் அமரந்தா மாதிரி ஆட்கள்லாம் நாளைக்கு அந்த வேலையை முழுக்கவே அதுவே பண்ணிடுமா? ஹியூமனுடைய ரோல் என்ன?
ஹியூமன்ஸோட ரோலை வந்து ரீப்ளேஸ் பண்ணாதுங்க சார். மோஸ்ட்லி ஹியூமன்ஸ் வந்து ஹியூமன் லெவல் இப்போ புக்ஸ் எல்லாம் நம்ம டிரான்ஸ்லேட் பண்றோம்னா அதுக்கு பின்னாடி போகக்கூடிய இது வேற மாதிரி இருக்கும். ஸோ ஜஸ்ட் ஒரு சின்ன சின்ன சென்டென்ஸை டிரான்ஸ்லேட் பண்ணுமே தவிர, ஸோ என்டையர் புக்ஸே டிரான்ஸ்லேட் பண்ணி அது வந்து ஒரு ஹியூமன் அளவுக்கு அது வர்றதுக்கு மேபி சம் டைம் எடுக்கும். என்டையர்லி ரீப்ளேஸ் பண்ணாது. பட் இது வந்து ரொம்பவே எங்க ஹெல்ப்ஃபுல்லா இருக்குன்னா, ஹியூமன்ஸை இன்னும் பெட்டரா மேல மேல போகிறதுக்கு ஒரு அசிஸ்டண்டா யூஸ் பண்ணா இது ரொம்பவே எஃபெக்டிவா இருக்கும்.
ஏன்னா இந்த மற்ற லாங்குவேஜ் சொன்னீங்களா, சைனீஸ் ஆகட்டும் அல்லது இங்கிலீஷ், மற்ற லாங்குவேஜஸ் எல்லாமே உலகத்தில் வர எல்லா சயின்டிஃபிக் டெஸ்ட்டு, லிட்ரேச்சர், பல விஷயங்கள் அவங்க மொழியில் டிரான்ஸ்லேட் பண்ணி வச்சுருக்காங்க. நம்மளுக்கு ரொம்ப கம்மி, எஸ்பெஷலி சயின்டிஃபிக் லிட்ரேச்சரில் வந்து தமிழில் ரொம்பவே கம்மி டிரான்ஸ்லேஷன். மற்ற எல்லா ஜெர்மன்லேருந்து எல்லாருமே அவங்க உலகத்தில் வர எல்லா ரிசல்ட்டையும் இங்கிலீஷில் வந்தாலும் அதை வந்து அந்த மொழியில் டிரான்ஸ்லேட் பண்ணி அந்த டேட்டா அவங்களுக்கு வைல்டு பிரமாதமாக வச்சுருக்காங்க. நமக்கு டிரான்ஸ்லேஷன் வந்து சயின்டிஃபிக் லிட்ரேச்சர், டெக்னிக்கல் லிட்ரேச்சர் வந்து தமிழில் இல்லாமல் இருக்கிறது எவ்வளோ தூரம் இது அஃபெக்ட் பண்ணும் ப்ரொடிக்ஷன்?
அது வந்து மேஜரா அஃபெக்ட் பண்ணுங்க சார். ஆக்சுவலா அந்த மாதிரி டேட்டா வந்து சைனீஸ் மாதிரி லாங்குவேஜ்ல நீங்க சொன்ன மாதிரி பாத்தீங்கன்னா ரொம்ப ரொம்ப அதிகமா இருக்கு. தமிழ்ல ஆல்மோஸ்ட் எதுவும் இல்லைன்னு தான் சொல்லணும். அது அஃபெக்ட் பண்ணும். அஃப்கோர்ஸ் அதுக்கு வந்து இன்னும் அதிகமா நிறைய பேர் ரிசர்ச் பண்ண ஆரம்பிச்சு அந்த கேப்ஸ் எல்லாம் எவ்வளவு சீக்கிரம் ஃபில் பண்றோமோ அவ்வளவு நல்லது. ஏன்னா மற்ற லாங்குவேஜஸ்ல வேற வேற லெவலுக்கு ஆல்ரெடி போயிருச்சு மாடல்ஸ். ஸோ நிறைய ரிசர்ச் நடக்கணும்.
ஆமா. இன்னொன்னு இப்போ சமீபத்தில் நடந்த புயல், மழை ப்ரெடிக்ஷன்ஸ் இருக்குல்ல, வெதர் ஃபோர்காஸ்ட், அதில் எவ்வளோ தூரம் இது ஹெல்ப் பண்ணும்? அந்த டேட்டா வந்து ரா டேட்டா தானே, அது ஈஸியாக நம்ம யூஸ் பண்ண முடியும். அது லாங்குவேஜ் இஸ் நாட் அபவுட் பேரியர்.
இது அதுக்கு வந்து தனியா டிஃப்ரெண்ட் எம்எல் டெக்னிக்ஸ்ல இருக்குங்க. அது வந்து ஆல்ரெடி பண்றாங்க. பட் இந்த மாதிரி சைக்ளோன்ஸ் வருது நம்ம ப்ரெடிக்ட் பண்றதும் ஆல்ரெடி நடந்துட்டு தான் இருக்கு. பட் ஸ்டில் நம்ம அதை ப்ரோஆக்டிவா அந்த மாதிரி ப்ரெடிக்ட் பண்ணதுக்கு அப்புறமா மக்களை சேஃப்கார்ட் பண்றது, அந்த மாதிரி கிரவுண்ட்ல இறங்கி செய்ய வேண்டிய வேலைகள் கரெக்டா செஞ்சா டேமேஜ் வந்து குறைக்கலாம் அப்படிங்கிறது என்னோட கருத்து.
இது வந்து ஒரு ஒரு பெரிய ஓப்பனிங், ஒரு திறப்பை கொடுத்துருக்கு. உங்களுக்கு வந்து பல துறைகள்லையும் வந்து இதை பயன்படுத்த முடியும். மருத்துவத்துல பல்வேறு துறைகளில் பயன்படுத்த நிறைய பேருக்கு ஒரு வேலை வாய்ப்பு, ஒரு மீனிங்ஃபுல் ஒர்க்கும் கொடுக்கணும்னு நினைக்கிறேன். நம்ம நிறைய இதை டிரான்ஸ்லேட் பண்ணி போட்டால் தான் நம்ம இந்த இதை யூஸ் பண்ண முடியும். நீங்கள் சொன்ன மாதிரி கரெக்டாக இந்த மீனிங்ஃபுல்லாக யூஸ் பண்ணணும்னா நிறைய விஷயம் டிரான்ஸ்லேட் தமிழில் பண்ணணும், டெக்னிக்கல் இன்ஃபர்மேஷன் பண்ணணும். அது பண்ணுறதுக்கு முயற்சி எடுத்தால் தான் இது வந்து இன்னும் அந்த டேட்டா பேஸ் ஒய்டாக தான் இன்னும் மோர் ப்ரிடிக்ஷன்ஸ் மோர் மீனிங்ஃபுல் கரெக்ட். ரொம்ப ரொம்ப நன்றி அபினந்தன். மிக சிறந்த ஒரு எக்ஸ்பர்ட் டாக் கொடுத்ததுக்கு ரொம்ப நன்றி.
ரொம்ப தேங்க்ஸ் சார்.
விஷாலாட்சி மேடம்,
அவங்க கை தெரியாம கை தூக்கிட்டாங்க முதல்ல.
ஹலோ,
சொல்லுங்க சொல்லுங்க சொல்லுங்க
பேசுறேன்.
ஹலோ அபிநந்தன், this is Abinandan.
ஹலோ.
Congratulations and ரொம்ப தேவை இப்ப தமிழுக்கு. I have some 2 to 3 questions on this. First,
sure, madam.
as you said, English to the other languages, there is a gap, and the reason is because of the less training data that is available in the Tamil language as of now. And because of this, it cannot understand the syntax and the semantic structure of Tamil as of now. So it cannot provide the coherent text. That's the problem with many of the pre-trained models that is available now. But my question is, when they claim that almost all the internet data of these languages has been already used, will there be a point this gap can be filled by them at any point of time?
Definitely. As I already shown, GPT-4 already exhibits a great deal of ability in Tamil as well. But the problem with that is those models are closed source, and they can decide to do whatever they want with it. But once some open source research starts, usually open source research develops far quicker than any closed source alternative. So I believe this is just a starting point, as they are training on extensive amounts of data. Even if it is 0.2%, if that data is like 100 terabytes, that's going to be a huge amount of data still. But inherently, the model itself didn't have the vocabulary to represent the language. So that was one of the reason why the smaller models are struggling. But the bigger models, they do pretty well, as seen in GPT-4's case already.
Okay, and one more thing is like, say if you have already have talked so much about the problem you have in the translation issues. My first question is, you spoke about the vocabulary when you have added some 12,000 vocabulary. So are these vocabulary or whole data, or it's whole tokens or sub tokens also it's associated to it?
So it actually has subword tokens.
Tokens.
Yeah.
Okay. And one more thing is, like, say if I'm a user, and one of the problem we have right now is creating a data set. That's the challenge. Since you have used the Stanford's and Microsoft's for your data set creation as well. Considering the Google translation, not Google translation, considering the translation is, I want to use it, be it LLaMa or be it GPT-4. I want to use it for a downstream task or a summarization or question answering. If I'm trying to use it, the problem I have is the data set. No, Tamilukku especially, அந்த மாதிரி I don't think any data set is available. So நான் இப்போ இருக்கிற, as you have done, if I'm doing any of the Englishல available இருக்க ஒரு data set நான் தமிழுக்கு convert பண்ணணும்னா, the translation part, can you say little specific, like how because Google translation நம்ம ரிலே பண்ண முடியாது. we know like ஒரு broader scale பார்த்தா அதோட இது நமக்கு தெரியும். பட் ஆனா உள்ள போனீங்கன்னா அதோட translation level is not very up to the mark. So what else can we do with respect to translation?
Translate ஆக்சுவலாக நான் கூகுள் டிரான்ஸ்லேட் ஏபிஐஸ் தான் யூஸ் பண்ணியிருந்தேன். ஸோ அந்த அல்பக்கா ஸ்டான்ஃபோர்ட் டேட்டா செட்ஸை தமிழுக்கு டிரான்ஸ்லேட் பண்ணுறதுக்கு. அண்ட் ஆஃப்டர் தட் ஃபியூ மேனுவல் இன்ஸ்பெக்ஷன்ஸ் அண்ட் கரெக்ஷன்ஸ் அது பண்ணியிருந்தது. எக்ஸ்டென்சிவ் அமௌண்ட்ஸ்க்கு இல்லை, பட் ஸ்மால் அமௌண்ட்ஸ்க்கு. பட் கூகுளோட ஆக்சுவல் டிரான்ஸ்லேட் ஏபிஐஸ் இருக்குல்ல, ஸோ பிஸ்னஸ் யூஸ் கேஸ் இருக்கு இல்லைங்களா, அது வந்து டிரான்ஸ்லேஷனுக்கு ஆக்சுவலாக என்னோட எக்ஸ்பீரியன்ஸ் படி அது நல்லாவே இருக்கு. I compared a few different techniques as well. Initially, I tried GPT-4. GPT-4, since it is very good at English and Tamil and many other languages, I tried to see if that can be used. But yes, it can be used, but it can be very expensive. If you are translating big data, huge amounts of data, it can be extremely expensive because GPT-4 charges about $0.001 dollar per token.
Yes.
So that can be really expensive. Google Translate and Microsoft's translation services are a great starting point if the data is not that complex. If, for example, these instruction data sets that I just shown, those data sets didn't even require any extensive manual work to edit those translations, since those are pretty simple human communications. So that worked out. But for specific data sets, like even a very complex medical related data set, if you want to translate that from English to Tamil, you will face a lot of issues.
Yeah, if it is more domain specific, it's more problematic actually.
Yeah.
And one more thing is like regarding fine tuning. Say if I'm using the LLaMa, say LLaMa, and if I want to fine tune to any of my downstream tasks, right? How much should be my data set? I mean, the size of the data set, minimum. Even though this is very subjective, I'm asking to like, what should be the minimum size of it to do a fine tune task? Say if I want to do a sentiment analysis or a question answering or summarization, anything for that.
Okay. So that also depends on the task. Some tasks can be performed in a zero-shot manner. That means without doing any fine-tuning. And some tasks can also be done with few shot techniques. First, I would suggest you to explore these prompting techniques like few shot prompting, chain of thought prompting, and tree of thought prompting. There are a lot of different prompting methods. Without fine-tuning, you can squeeze out a lot of great performance from these models. If those fail, if you're going to fine-tune it for very complex use case like making it act like a salesperson or something else, like in that case, it also still depends on the data. So how you want that to be. If how you want is really complicated, then you need a big enough data set to represent all of the complications that you are looking to have. So but fine tuning is actually very cheap. Even if you have like 200, 300 samples, very high quality samples, which actually perfectly convey exactly how you want it to behave, I think it will generalize to that pretty well.
Okay. Like one of the problem with any of the pre-trained models, maybe people are still struggling, is the hallucinations by the model. Have you done anything like more specific on this to manage or control it in any way, or is it needed in the first place?
Yeah, that's a very good question actually. So most of the LLMs today hallucinate a lot, especially when you're chatting with the model. When you go down the chat, like when you have a lot of chat messages already there previously, the model starts hallucinating when you ask questions that are referenced previously. So even LLaMa model also hallucinates a lot. But one way I found way to overcome is like using better prompt engineering that can actually fix a lot of these hallucination problems. Also, recently there are a lot of these other models have also come out, like Mistral and all of those. Those are comparatively better than Llama in terms of hallucination, but still all the LLMs are do hallucinate. Even the best of them do. We can try to overcome that by better prompt engineering and better fine tuning, in my opinion.
Okay. Okay. So I can use, using Google Colab right now, is it sufficient for me to use the model?
Yes, with Google Colab's GPU, free GPU, you'll be able to easily load up the model. In the 7 billion and also the 13 billion model is possible to load up in
Okay.
8-bit precision.
Okay. Thank you so much, Abinandan. Thank you.
Thank you. Thank you.
முடிச்சிடலாங்களா ஐயா?
முடிச்சிடலாங்க.
திரு
அபிநந்தன்
திரு அபிநந்தன் அவர்களுக்கு எங்களது உத்தமம் சார்பாக எங்களது மனமார்ந்த நன்றியை தெரிவித்துக் கொள்கின்றோம். மிகச்சிறந்த உரையை வழங்கி, விரிவுரையை வழங்கி அனைத்து கேள்விகளுக்கும் பதிலளித்தார். அவருடைய ஆராய்ச்சி தொடர எங்களது மனமார்ந்த வாழ்த்துக்கள். நன்றி, வணக்கம். மீண்டும் ஒரு விரிவுரையில் சந்திக்கலாம்.
இன்னொரு வாய்ஸ் கேட்டது, ஏதோ கொஸ்டின் பண்றதுக்காக இன்னொருத்தர் பேச ஆரம்பிச்சாங்க. அந்த நேரத்துல நன்றி சொல்ற யாரும் பேச இருந்தாங்க, யாரும் கேட்டு அப்பமா முடிச்சு
சார்
பேசுறாங்க. அமரந்தா பேசுறாங்க.
சொல்லுங்க சொல்லுங்க.
அபிநந்தன்
சொல்லுங்க மேடம்.
இல்ல, ஒரு பர்டிகுலர் யூஸ் கேஸ்க்கு இப்ப நாங்க உங்களோட மாடல், நீங்க ஃபர்ஸ்ட் ஒரு பேஸ் மாடல் ட்ரெயின் பண்ணி வச்சிருக்கீங்கல்ல, அதை எடுத்து எங்களால ஒரு பர்டிகுலர் யூஸ் கேஸ்க்கு ஃபைன் டியூன் பண்ண முடியுமா?
கண்டிப்பா பண்ணலாங்க.
அப்படிங்களா? சோ நான் கரெக்டா கேக்குறேன்னா, உங்களோட பேஸ் மாடல் எடுத்து எங்களோட அப்ளிகேஷனுக்கு நாங்க ஃபைன் டியூன் பண்ணிக்கலாம், கரெக்ட்டுங்களா? யூஸ் கேஸ்க்கு
கரெக்ட்டுங்க. ஆக்சுவலா பேஸ் மாடல்ல வச்சு தான் ஃபைன் டியூன் பண்ணணும் ஐடியலி. பட் உங்களோடது வந்து அது யூஸ் கேஸ் பொறுத்து நீங்க ஈவன் இந்த இன்ஸ்ட்ரக்ட் மாடல்ல கூட ஃபைன் டியூன் பண்ணலாம். நீங்க அல்பகா ஸ்டைல் ப்ராம்ப்டிங் மெத்தட் தான் யூஸ் பண்ண போறீங்கன்னா மேபி தி இன்ஸ்ட்ரக்ட் மாடல் கூட ஃபைன் டியூன் பண்ணலாம். பட் நான் வந்து பேஸ் மாடல்ல ஃபைன் டியூன் பண்றதை ரெக்கமெண்ட் பண்ணுவேன். பட் அப்படி பண்ணும்போது நீங்க நல்லா டீசென்ட் குவாலிட்டி டேட்டா செட்ல ஃபைன் டியூன் பண்ணீங்கன்னா ரிசல்ட்ஸும் நல்லா இருக்கும்.
ஓகே. இப்ப நான் ஒரு சார் கேட்ட மாதிரி ஒரு சயின்டிபிக் ரிசர்ச், ஒரு பர்டிகுலர் டொமைன்ல ரொம்ப கம்மியான ஒரு விஷயத்தை எடுத்துக்கிட்டு நான் அதுல ஒர்க் பண்ணணும்னு நினைக்கிறேன்னு வச்சுக்கோங்க, அதுல பெட்டர் ரிசல்ட்ஸ் கொடுக்கணும்னு நினைக்கிறேன் அப்படின்னா நீங்க என்ன மாதிரி சஜஸ்ட் பண்ணுவீங்க? ஒர்க் ஃப்ளோ எப்படி சஜஸ்ட் பண்ணுவீங்க? நான் கேக்குறது உங்களுக்கு புரியுதுங்களா?
புரியுதுங்க. இதுல அப்படி வந்து நான் என்னோட எக்ஸ்பீரியன்ஸ் சொல்றேன். ஸோ நான் வந்து ஒரு ஃபியூ மந்த்ஸ் முன்னாடி இதை ட்ரை பண்ணியிருக்கேன். ஸோ ரொம்ப நீச் டொமைன், மெடிக்கல் டொமைன் மாதிரி வந்து ஒரு டொமைன்ல இங்கிலீஷ்ல தான் பண்ணேன். ஸோ இங்கிலீஷ்லேயே லாட் ஆஃப் டேட்டா இருக்கு. ஸோ இங்கிலீஷ்லேயே பண்ணும்போது மேஜர் சேலஞ்சஸ் எக்கச்சக்கமா இருந்துச்சு. பட் ஸ்டில் ஹலூசினேஷன் மேஜர் ப்ராப்ளமா இருக்கும் சம்டைம்ஸ். பட் வி நீட் டு ஓவர் கம் தட். ஆனால் ரொம்ப காம்ப்ளிகேட்டட் யூஸ் லைக் மெடிக்கல் ஃபீல்டில் ஒரு சேட்பாட் பண்ணணும் அப்படின்னா நம்ம ரொம்பவே மேனுவலாக கியூரேட் பண்ணி நம்ம கொடுக்கக்கூடிய டேட்டா ரொம்ப ஹை குவாலிட்டியாகவும் ஆக்சுவலாக அதில் எந்த ப்ராப்ளம்ஸும் இல்லாத மாதிரி இருக்கணும். அப்படி இருந்துச்சுன்னா நம்ம மோஸ்ட்லி இன்ஜினியரிங் டெக்னிக்ஸ் வச்சு டீசன்ட் மாடல் நம்மளால கண்டிப்பாக பண்ண முடியும்.
ஓகே. அப்புறம் இன்னொரு கொஸ்டின், இப்போ நீங்க வந்து கூகுள் பாடோட லாங்குவேஜ் மாடல்ல ட்ரை பண்ணி பார்த்துருக்கீங்களா? அதுலேயும் தமிழ்ல வந்து இட் இஸ் ரெஸ்பாண்டிங் பேக் இன் தமிழ். அது வந்து நம்ம இன்புட் வந்து ஈவன் ஆடியோ இன்புட் கொடுக்கலாம். ஆடியோவில் நான் கொடுக்கும்போது அது அப்படியே டிரான்ஸ்லிட்ரேட் பண்ணி எடுத்துக்குது இன்புட்டை. அதுக்கப்புறம் அந்த இன்புட்டை உள்ள எடுத்துட்டு இட் இஸ் கிவிங் பேக் தமிழ் அவுட்புட்.
ஆமாங்க, அது ஆக்சுவலா நானும் பார்த்திருந்தேன். பிகாஸ் அது வந்து ரொம்பவே லார்ஜ் மாடல். ஸோ அது வந்து ட்ரெயின் பண்றதுக்கு அவங்க வந்து மில்லியன்ஸ் அண்ட் மில்லியன்ஸ் ஆஃப் டாலர் செலவு பண்ணியிருப்பாங்க. ஸோ அந்த அமௌண்ட் அண்ட் ஸ்கேல் ஆஃப் டேட்டா அண்ட் அவங்களோட இன்ஜினியரிங் டீம்ஸ் ஹண்ட்ரட்ஸ் ஆஃப் பீப்புள் டீம் வேர்ல்டுலேயே பெஸ்ட். ஸோ வாட் தேவ் டன் இஸ் ரியலி கிரேட்டுங்க. ஆனால் அதுலேயும் இன்னும் என்ன பிரச்சனைனா அதுவும் ஓப்பன் சோர்ஸ் கிடையாது. இப்போ நீங்கள் நினைச்சீங்கன்னா அந்த மாடலை எடுத்து ஃபைன் டியூன் பண்ணுறதுக்கு இப்போ வரைக்கும் பாசிபிள் கிடையாது உங்களோட டவுன் ஸ்ட்ரீம் டாஸ்க் ஃபைன் டியூன் பண்ணுறதுக்கு. பட் ஈவன் ஃபியூச்சரில் ஓப்பன் ஏஐ மாதிரி அவங்க ஃபைன் டியூனிங் ஆப்ஷன் கொண்டு வந்தாலும் இட்ஸ் கோயிங் டு பி வெரி எக்ஸ்பென்சிவ். ஸோ அந்த கேஸில் ஐ திங்க் ஓப்பன் சோர்ஸ் மாடல்ஸ் ஆர் ஸ்டார்டிங் டு கேட்ச் அப். ஸோ நம்ம இன்னும் கொஞ்சம் அட்வான்ஸ்மெண்ட்ஸ் கண்டிப்பாக பார்ப்போம் கம்மிங் இயர்ஸில், கம்மிங் மந்த்ஸில்.
எஸ்.
ஓகே, தேங்க்யூ அபிராமன்.
தேங்க்யூ.
அபிநந்தன், அமரந்தா பேசணும். நான் ஒரு நிமிஷம்.
வணக்கம் அபிநந்தன்.
வணக்கம்.
உங்களோட ஸ்பீச் நான் கேட்டேன், அற்புதமா இருந்தது கேட்கறதுக்கு. ஆனா ஏஐ பத்தி நான் அதிகம் எனக்கு எதுவும் தெரியாதனால என்னால அதுக்குள்ள போக முடியல. நான் நினைக்கிறேன் நம்ம தொடர்ந்து இன்டராக்ட் பண்ணாக்கா அதுக்கப்புறம் அது பாசிபிள் ஆகும்னு நினைக்கிறேன்.
கண்டிப்பாங்க.
ஆனா வாழ்த்துக்கள் இந்த அச்சீவ்மெண்ட்டுக்காக, என்னுடைய மனமார்ந்த பாராட்டுகள்.
தேங்க்ஸுங்க, ரொம்ப தேங்க்ஸ்.
நன்றி.
முடிச்சிடலாங்க.
முடிச்சுக்கலாங்க.